Alright, we're on to problem number 9, and just a quick note, if you were following along for problem number 7, you'd realize that the answer should actually be 1.7 times 10 to the 5th, because they asked for two significant digits. Alright, so 1 digit, 2 digits, so that would have been the correct answer. But moving on, number 9, when n is squared, it's less than 150. Alright, n is an integer. We might say n is an element. Integers. Oh. So actually, never mind. That would, integers are normally indicated with this symbol. This is the symbol for integers, and that comes from Zahlen, a German word for number. But anyway. On to the problem. N is an integer. Its square is less than 150. What is the sum of all possible values of n? So n could be, okay, n could be 1. Alright, 1 squared equals 1. 2 squared equals 4. And we could keep going, okay? That's going to be tedious. This is the simple way to do it, but I also, a quicker way to do it is to search, right? Search by going higher, and we'll just say 15, right? What's 15 squared? 15 squared is equal to 225, alright? So we know it can't be 15. 15 is out. We know 10 squared is equal to 100, so 10 is in, and it's higher than 10. We know 12 squared, right, is 144, and 13 squared is 169, so n, 1 is less than or equal to n, which is less than or equal to 12. Okay, and then it says, what is the sum? And so the sum of all numbers from 1 to 12, right? 12 plus 11 plus 10 plus 9, right? Plus 1, what's that equal to? Right? And the important thing here is not that you do this addition, but that you figure out how to do this. Okay, and so to add all the numbers from 1 to n, right? Here's the quick way that I can show you how to remember this formula. Okay, there's a multiplication method you can use. Use multiplication to add, right? And typically we think of adding, alright, we've got all of these little x's, we've got 4 and 3, right, and 4 times 3 equals 12, and that is faster than adding 3, plus 3, plus 3, plus 3, right? But we'll notice here is the, let's say we wanted to add all of the numbers from 1 to 12, okay? we've got, in this case, right, a line of symmetry. Oop, never mind, I drew that incorrectly. Let me... Yep, here we go. I'm going to change the color here. So we've got this line of symmetry. Okay? We know that if we cut this in half, okay, we'd have 4 times 3 divided by 2 equals 6. And what do we notice here? 6, right? 6 equals the sum of 3 plus 2 plus 1, right? And I'm just going to circle that for you in blue. 3, 2, 1. So if somebody tells you, okay, to add up all the numbers from 1 to 12 or 1 to 100, alright, you can draw out all of these squares, okay? No, you'd never do that. What you'd do is you'd say, alright, n equals 3, okay? Well then, the sum, right, from 1 to 3 equals 3 times 4 divided by 2 equals 6, alright? Or in general, n times n plus 1 divided by 2, right? That's it. So 12, in the case of our problem, times 13 divided by 2 equals 6, right, over 1 divided by 13, right, because we just factored out. Okay? And 6 times 13 is a much easier problem to do. It's equal to 78. So that's the answer. The big thing to learn here, right, is how to add from 1 to n. And the important thing, don't remember alright, don't remember, prove. Right? Convince yourself that that must be true. So let's move on. We're going to do number 10.